All right, now we're going to go through our steps. Now, it's been interesting so far, but this is the point where things get very, very, very interesting, okay? So please recall our multiple linear regression model from week 2. Okay, so recall, so this is step 6A, data reduction, and step 6B, where we're doing the analysis and then presenting it in table form. Right, so our quantitative results and our multiple linear regression indicated that class assignment, right, was the strongest predictor of the dependent variable attending class 0 to 7 days. All right? Now keep this in mind. Now, what we also found the same thing, right? And when we looked at the dependent variable dichotomized, right? So when it was dichotomized into attending class 3 days a week or more, right? And we made the binary logistic regression model, right? Class assignment, you see by the big blue arrow, had the biggest odds ratio, the biggest effect size, right? 6 times more likely to attend class if assigned to evening classes, right? So that was the biggest, strongest predictor of attending class 3 days a week or more, which is what the administrators wanted to know, all right? So these are the old findings, or the prior findings, you might say. And of course, we have our qualitative data analysis, where we identified our themes, right? So the first theme were things that encourage attendance. I had 3 sub-themes, right? The instructor preference, moving class to the morning, positive instructor traits. And then our next theme were barriers to attendance, theme 2. And there was 4 sub-themes: negative instructor traits, lack of interest in class, drawbacks that related to going to evening classes, and the physical demands presented by class, which is sub-theme 4. Right? So now here, the preference regarding one instructor over another seems to be the driving factor in attending class, right? 77% of residents said they're attending class because of the presence of Miss Albright. Now that's different than what the quantitative said. The quantitative said it was class assignment. Now the qualitative is suggesting they're not going in the evenings, you know, because they like the evenings. They're going in the evenings because they like Miss Albright. So how can we, here's a question, how can we put these 2 data sets together, right? So they're a little contradictory, but we don't want to leave them contradictory. We want to merge them, right, and see what's really going on based on the input of both qualitative and quantitative strands. How can we do that? Right, so keep in mind, step 6C is data transformation. Now, we're going to be transforming our qualitative data into quantitative variables. Right? Now, when we do this, it can be done in several ways. Right? There's not just one way to do it, and the variables can have different structures and forms and tell us different things, which is pretty interesting. So you're looking at the data from many dimensions, many angles, right? You can get the whole story not only qualitatively, but when you make the qualitative into quantitative, you're also looking at those dimensions quantitatively, all right? Now, the theme 1, right, sub-theme 3, is positive instructor traits that encourage attendance, right? So this sub-theme has 3 categories. So the positive instructor traits that encourage attendance are, right, there's 3. They are, now before we go to it, right, keep in mind, since there's 3, right, much like the doctor prescription, remember the doctor prescription variable in our quantitative, where it was doctor prescribed no, doctor prescribed yes, doctor recommended, then it was 3 separate variables coming from one main categorical variable, right? So the same thing here. we could make this one main categorical variable, right? Where it's you know, they indicated 1, 2, or 3 of the traits, or they could be separate yes/no variables, like this, right? So they could either be separate, as in variable 1, you know, the resident indicated being enthusiastic, right, was a positive trait that got them to class, yes/no. Variable 2, you know, calm voice. The instructor had a calm voice that got them to class, yes/no. Or 3, residents that indicated both enthusiasm and a calm voice got them to class, right? Or it could be one variable, right? It could be one variable, such as positive instructor traits, with the response categories 1, 2, and 3, enthusiastic, calm voice, or enthusiastic and calm voice. Now we'll look at this a little deeper in terms of theme 2, the barriers to attendance. Now, if you recall, barriers to attendance had 4 subthemes, right? So we could actually create a variable called barriers to attendance, you know, with 4 categories, right? Or, as listed here, we could make each subtheme a yes/no quantitative variable, and we'll show this in SPSS, but we'll just discuss it first. Specifically, the first subtheme was negative instructor traits, right? So we could create a variable flagging or identifying if the study participant identified that a negative instructor trait was a barrier to class, yes/no, right? Second, we could have a second variable 2, which is subtheme 2, lack of interest in class. Did the respondent indicate that lack of interest in class was a barrier to go into class? The same with variable 3. Did the person indicate that the drawbacks attending evening classes was a barrier to class? And 4, right, were the physical demands of class a barrier to class? So we could indicate 4 separate variables, all yes/no. Did the respondent indicate this? Or, as we said, we could create one categorical variable called barriers to attendance with, you know, each response category is one of the subthemes. So it would be one variable called barriers to attendance, and the response would either be 1, 2, 3, or 4, right? You might have to create more responses. You'll see if a respondent indicated 2 of those, right? So 1, 2, 3, 4. 5 might be if they said negative instructor traits and lack of interest. That might be category 5, right, if there's combinations. Now, another way, so this is the third way. The third way, we could convert that qualitative data into a quantitative variable. So this is the third way. The first one, yes/no variables. The second way, one categorical variable with the response categories. Right? This is the third way. So we might sum the barriers of attendance. So this is why we always code yes/no as 0 and 1. Right? This is why. So if we decide we want to count how many barriers, irrespective of what they are, but how many barriers each person indicated, if we code yes/no 0 and 1 and add them up, well then 4 yeses is 1, 1, 1, 1, a score of 4. And 4 no's is 0, 0, 0, 0, a score of 0. So it ranges from 0 to 4. So always keep yes, no, 0, and 1. So if we add them like that, negative instructor traits, lack of interest, right, the yes, no variables, drawbacks to evening physical demands, we would sum them to get a value of 0 to 4, representing the number of barriers each resident indicated, right? So here's our multiple dimensions. There's, you know, is a specific, you know, barrier, such as lack of interest, you know, a bigger barrier than the others, looking at them in the yes/no fashion, right? Or, irrespective, is it the number of barriers that are indicated that really, impact going or not going to class, right? So these are different dimensions gleaned from the qualitative data. So next, it's useful to note, right? So step 6D, data correlation. It's useful to note what variables seem to be related to another, among and between the data sets, right? So what we're seeing in the qualitative data is that class instructor, that's really it seems to be the most salient predictor of class attendance, right? So we want to put that together with our quantitative data and include it in our analysis, right? And it also makes sense if we're explaining class attendance that we would want to include barriers, right? Because a barrier to attendance should theoretically impact attendance, right? But that's theoretical. We want to know if it's true, right? If it was true theoretically, we don't need quantitative analysis, right? So that should be the case, but we'll include the barriers in quantitative analysis to see if it is the case. Okay, so we're going to end up with one data set, right? And we're going to have all those variables in it. Right, so little added data note here. So what happened in our process was we noticed class instructor was an important variable, but we don't have that data, right? It's not in the quantitative data set, and the participants couldn't tell us, who taught each class during the month. So we go back to the administrators of the community residents, right? The retirement community residents. And we tell them we need this data, right? So we say we need to know who taught each class during the month. So they actually give us those data. Then they also inform us that when the tickets are sent out to attend class, it's printed on the tickets who the class instructor is. So the residents know who will be leading the class, right? Each respective class. They know who's going to be there teaching it before the class. So what does that tell us? That tells us that might have something to do with their reasoning process about going to class or not going to class. It'd be different if they didn't know, because if they walk to the residence hall and they say who's teaching it and they're already walked there, they might stay irregardless. But if they know, that might motivate a person in actually leaving the house and going to class. Right, so 6E, step 6E, data consolidation. This typically takes a good amount of time, but it's well worth it, right? So we're going to enter the qualitative data, which are the text comments, right, into our quantitative database, right? So the variables will be string, right? In SPSS and such software, string variables are where words are entered, right? And we're going to make parallel variables that are numeric, right? So we're going to code each variable and numerically, so it could be included in quantitative analysis, right? So then all qualitative data can be presented descriptively and included in inferential analysis. The end result is going to be one data set in the SPSS software. Right? Now note, when we take the qualitative responses and put them in the quantitative database acts largely like the qualitative software does in storing text responses in certain categories, making them available to us, right? Being able to count them and do searches and look at the content and all. So this is the point where we mentioned earlier that the quantitative software can do many of the beneficial things that the qualitative can also do. So if we actually look, right, so if we go, we have right here our study interviews. Now, as we said, when you use the software, you would say highlight, right? Well, maybe not highlight that. But you would highlight, for example, prefers morning classes, right? And you would code it in the qualitative software, and it would be put in one list to see all together because it would represent, one theme and all that. So what we could do here is you just go there and you can actually copy it and then go to the quantitative software, right? And we look in data view, and if we go over to those variables, right, like right here. So we have right here a variable. So like I said, it's a lot like the qualitative, where you put it right in the variable to see in the variable. But when you run descript on the variable, you actually get all the responses for that qualitative data. Right now, as we said, there's a parallel quantitative data variable, so we could do an analysis, and that's right here. So you could say TH1 theme 1 sub 1 sub theme 1. So theme 1 sub theme 1 is when they make a comment, indicating, recommending, or requesting Miss Albright. So then we put the actual comment that the person said. Right, so we have them all in a row. Plus we put it in here so we don't misclassify anything. So if we say that's what they indicated, we can actually see what they said. And then we put a yes here. So whenever they made a comment, we put a yes. And this, if you click this, these are numeric, right? So there's a 1 for yes and for no, as we said, right? So where there's a no, that's 0. So, and we put no comment here. So they didn't put any comment regarding Miss Albright. And where the comments are is right here. And as we said, this variable can come out several ways. So if we run a descriptive on it, right, so that's theme 1, and then theme 1, right, and then this, right, just like in the qualitative, we get the big long list of responses, and sometimes people may say the same thing among people. And then down here, we have 77, right? Remember, 77 residents indicated they prefer Miss Albright. And here it is, yes, 77, no, 23. So we can compare directly, is there a higher level of mean attendance for the people that said yes or no, if we like. Right? So also, we also want to keep in mind this. There may be a need to compare the two data sources, right? So before we get too far off, right, in SPSS, we want to also keep in mind that if there is a different number of data sources, right, for the qualitative and quantitative, we want to make sure, like for example, look at the demographics, right? So if there's 100 residents interviewed, and for the quantitative, and only 30 for the qualitative, we want to make sure the 30, so if the 100 are men and women, we want to make sure the 30, for example, are not all men or all women, because then it would be a little bias in reference to the qualitative, or it could be. So we want to check the data sets together, right? Now we know in our data set it's everybody, so we don't have to worry about that. Now, we might want to run descriptives and univariate analysis, as we just shown, on all the qualitative variables, which we will also do. Right? So here we have, right, our data integration. So this is where our analysis is coming in, right? So then we're looking at if class attendance is impacted by, right, 1, barriers, the ones identified in theme 2, and 2, the new independent variable, class instructor, right? So the independent variable is explaining the dependent variable. So that makes the topic of interest, which class instructor has become. And so, of course, the variables significantly related to class attendance at the bivariate level are going to be entered in the regression models, right? The ones from week 2, the multiple linear and binary logistic regression models will have the new variables that are significantly related to class attendance included. Now, recall the bivariate test key, right? So this is telling us what variables we need, right? A and B, right? So what variables we need to combine, and then what test. Right? So we're going to plug in, here we go, we plug in our variables that we need to compare, okay? So if we made barriers into categorical yes or no, did the person report at least one barrier, and we're comparing that to class attendance from 0 to 7 days, we use a t-test, and the same thing with class instructor. Did they prefer categorical 2, Miss Getline or Miss Albright, and then referenced against class attendance, a t-test? Now, if we kept the variables as one categorical, right, one categorical variable with the responses, you know, each subtheme is a response, and compare it to the continuous class attendance and ANOVA. And if we made our barriers 0 to 4, where we added them up, remember, and compare that to class attendance, 0 to 7 days, we use a correlation, okay? So let's go ahead and do that, right? So for example, now we're just going to go right here. Now the first thing we might want to do, of course, as we said, is look at the data descriptively, the univariate analysis. So let's look at our, right, so right here, theme 2. Okay, and we want to go all the way down to the summed number of barriers. So you can see there's a lot there, right, that's been combined. We put it down, we click OK. And then this is what we say. So theme 2, sub-theme 1, we have all the comments for negative instructor traits. Right, so what did everybody say that they found to be a negative instructor trait that kept them from attendance? Right, so you can see them all there. Now important, you can see right here, no comment right in the middle, 84, right? That's people that didn't make any comments regarding the negative instructor traits. And then you want to check that against the numeric variable we created right here, right? So there's barriers to attendance, negative traits, and just like we have in the qualitative, it's 15 yes, and then the sub-theme 2, right? So they're all here in a big list that you could print out to describe. So we have our no comment here, and then there's 25 that said yes, and then we go all the way down through the sub-themes and their respective numeric variables, right? The yes, no, did they report this theme? Then we get to our categories of barriers, and then as we said, if you look at the bottom here, there are a couple of combinations. So this person said lack of interest in class and drawbacks. So 2 people actually said that together, right? And then 1 person said negative instructor traits and drawbacks of the evenings, and this is lack of interest and drawbacks, negative instructor traits of physical demands, and then the rest only indicated 1, or in the case of no comments, right, no discouraging factors to report 35. And so that's in concurrence with our qualitative data. If you recall, we said 65 people noted barriers. So if 65 did, 35 didn't out of the 100, and these are those, right? So then if we keep going, you'll see we collapsed these, because if we want to use this in inferential analysis and do an ANOVA, you can't really use 2, 1, and 1. So we collapse that in the second one where it says categories of barriers, multiple collapse. The multiple people that indicated multiple, negative traits were collapsed into 4, which is still too small technically for a one-way ANOVA, but it's much better than 1 or 2. So here we go. The no discouraging factors report is the 35, and then the rest are below it. Now you'll notice, for example, the negative and structured traits, I believe there was 15. There's 2 missing. Where are they? Right there in the multiple, right? So these have like 1 or 2 missing from each because the person that's in the multiple is down here and not in the single category. And then the way it turned out, we wanted a continuous variable, right? We wanted a continuous variable to test, to correlate with number of days attended, but you'll see there's only 4 people, as we said, that noted 2 factors. So it goes 0, 1, 2, which is continuous, but the last category only has 4, which it'd probably make more sense to collapse this into the 61 and make it just indicating 1 or more, barriers. So those are considerations you have to make, based on the data. You never know how it's going to come out, right? Okay. So again, refer to our bivariate test key, right? So perhaps the first thing we might want to do are our t-tests, right? So we do the t-test comparing one or more barriers, right, or the class instructor, right? So let's look at our very interesting class instructor variable first. So we go here, we go to compare means, if you'll recall, independent samples t-test, right? I'm purposely going slower. Okay, here we go. Stretch that on out now. And we want to say, did the resident report 1 or more barriers? We put that in there. Of course, that's 0 and 1 define groups. 0 meaning no, 1 meaning yes. Continue. And then we put our continuous variable, right? Class attendance here. Drum roll, please. Okay, okay. Here we go. So recall, the first thing we look at is statistical significance, which is in the center column of the second table. So we see it's 0.44. So the finding is not statistically significant. So we don't consider the rest of the test. Okay, so if we go back and we look at the same thing, independent samples, we take out that and put in class instructor. Right, so meditation class instructor, and that's a 1 and a 2. And then click OK, or paste if you're saving the syntax, which is recommended. Now we see something very interesting. If you look at the sig, right here, 0.000, statistically significant, way below 0.05, then you want to look up here at the mean, right? So this is also included in our slides, which we'll go through. But preliminarily, you see Ms. Gantenlein, when people are assigned to her class, there's an attendance of about 2.5 days out of the week, 2.5. But Ms. Albright, the same amount of people are assigned to her, and they attend almost 5 days out of the week. Very interesting. So next, don't forget, we wanted to use the ANOVA to look at what? The categorical, right? Categorical, the single categorical variable with all the response categories. Right, so if we made our barriers into the 1, right? The categories of barriers with the multiple collapsed, we put that in there. Then we put class attendance in here. At this point, you should be feeling considerable suspense. It's very exciting. So we could click post hoc, but remember that one category had 4, so it's probably not going to produce a post hoc test. But it's good practice. Then we put in options descriptive to see the mean. Then paste or OK. So then we have here now the first thing we look at is in the second table marked ANOVA 0.84. So it's not statistically significant, indicating there is not a significant difference between mean scores within these categories. And if you look at the mean scores, you see the people that reported, no barriers, they attended on average almost 4 classes a week. And then it goes down where it's right between, say, like 3 and 4 for everybody. Right? So negative instructor traits, they attended a little over 3. Right? Lacking interest in class, they attended almost 4, just like the people that didn't report any barriers. Right? We wouldn't take these means seriously because the test is not significant, but you could see why it's not significant, because all the means seem related, right? Very close. So the last one, right? So we just did this one for the ANOVA. Now the last one are continuous and continuous. Again, we probably wouldn't do this because it's not much of a continuous variable with only 4 people, with more than 1. But if it were per se, this is what we do. So we go to analyze and then correlate. So like each of these is looking at the qualitative data from a different angle. So it's important to know how to make the qualitative data into all these different structured variables. So we take the summed number of barriers, the class, and then we correlate it with, class attendance 0 to 7. And then it tells us, right? So the probability, this middle number, 0.361, is way below 0.05, so there's not a significant correlation. So what did the bivariate analysis tell us? It told us that the t-test for Ms. Gettenlang and Ms. Albright regarding days of the week attended had a significant mean difference. So as we said, when you look at the second box where it says sig, we see it's below 0.05. It's a significant difference between the means, right? Then whose mean is significantly higher is Ms. Albright. Right? When people are assigned to her class, they attend on average 5 days a week. When people are assigned to Ms. Gettenlang's class, it's half that, about 2.5 days a week. The plot thickens. Right, now, we also want to look at the same thing regarding, when we divided our dependent variable into 3 days a week or more. Right, so fewer tests here, right? But if we look at the bivariate test key, when we have a continuous predictor, like barriers 0 to 4, and we're comparing it to a categorical, a dichotomous dependent variable, we would use a t-test. And when we have categorical predictor and a categorical outcome, a dichotomous outcome, we would use a chi-square, right? So go ahead and do that really fast. Now, here's what's interesting. Will we get the same results? Many times, well, sometimes, when you divide the dependent variable and make it dichotomous, you actually don't get the same results as when it's continuous. As if to say, the dependent variable is related to different predictors when it's dichotomous or when it's continuous, right? And you could imagine that's a kind of a pain in the neck to explain in a manuscript, right? Because you can't really definitively say what predictors are or are not related because you have conflicting findings. Well, we have conflicting findings. So the first thing we want to do is take that out and put attending class at least 3 days a week in there. And of course, that's 0 and 1 for yes and no. Take out class attendance. And again, this is not much of a continuous variable for us, but then put the sum number of variables in there. We click OK. Again, See the second box, center column, the significance is way above 0.05. So there's not a significant relationship between the number of barriers and going to class 3 days a week or more. So now we want to look at our chi-squares. Recall, this is what we do. We take our dependent variable and we put it in the column, right? So attending class at least 3 days per week. Then we take the predictors of interest, right? Which, if you recall, right here, class instructor, and then we might look at, barriers if we like to, or barriers 1 or more, right? We could look at all that, but the big thing is our class instructor, because that seems to be, right? So class assignment, meditation class instructor, we put that there, right? And then we might put, did the respondent report, any barriers, right? And we could also put the categories of barriers if we wanted. Then under statistics, we click our chi for chi-square. Continue. Under cells, we click our row. Yep. And then paste or OK. So here we go. We have a chi-square, so valid. All 3 tests have all 100 people. That's nice. Now, interesting. We also have this in the slides, but you'll see in the second box, statistical significance, a difference between attending class 3 days per week and instructor. So we'll look into that further. However, when you go down and you look, so did the report more barriers to class attendance, right? So not so much, right? So the real variable of interest becomes, right, so the only thing significantly related is this chi-square, and we have these to look at, right? So we see it's significant on the bottom. We also see that the percentage of residents that attend class 3 days or more for Ms. Gettenlein's classes is 50%. However, 92% of the people assigned to Ms. Albright's class come to class 3 days a week or more. So that's a big predictor. So almost everybody assigned to her class shows up. So then we enter, right, as we said we would, class instructor to the model, right? And then we see it is, in fact, the strongest predictor of class attendance in our multiple regression model, right? The findings change. So now class instructor is the biggest predictor. Now pay attention to this. If you compare the first model and the second model, you see class assignment was the strongest, significant, and the strongest predictor in the first model. But if you look at the second blue arrow, the one in the middle, you'll see now class assignment is no longer statistically significant in the model, right? So now class assignment doesn't really matter once you consider who the instructor is. Now this can only be indicated quantitatively. You see the same thing with the binary logistic. So we put the instructor in the binary logistic. That becomes the most significant predictor of attending class 3 days or more. So people that get Ms. Albright are 18 times more likely to attend class 3 days or more. And then if you compare the two models again, in model 1, this was the strongest predictor, right? Significant, statistically significant, and 6 times, 6.44, 6 times more likely, that people go to class 3 days or more. But in the second model, that middle blue arrow also indicates now class assignment is no longer significantly related to class attendance, right? So here's what you need to keep in mind. When an added predictor turns a significant predictor no longer statistically significant, as what happened with, class assignment, it's that the new predictor explains the variance in the dependent variable formally explained by the original predictor. So in other words, when we consider the instructor, right, the variance explained in attendance by class assignment no longer matters, right? It's explained by instructor, right? So you could say the dependent variable was predicted over and above by the new predictor, which is class instructor, right? So it's basically saying that when you consider class instructor, class assignment really doesn't even matter anymore in explaining class attendance, right? So clearly the independent variable class instructor is the strongest in our regression models. But is it a true confounder? Remember we said the confounder is related to the independent and dependent variable and distorts our findings. So if we do, so we know, right, instructor is related to class attendance, but is it related to the original independent variable class assignment? If you do a chi-square, right, you'll see yes, right? So class instructor in the morning, right, Ms. Gettenline teaches 74% of the time in the morning, right? And then Ms. Albright teaches 74% of the time in the evening, and the bottom box, you see the sig, is statistically significant, so there's a significant difference where Ms. Albright is much more likely to be teaching in the evening, right? So a true confounder, right? So we've identified with our qualitative analysis a true confounder that was like suppressing our findings, right? Now, confounders are traditionally huge reasons why study results are distorted or incorrect, and wrong decisions are made, like moving the classes based upon them. Now, variables don't need to be confounders to have a negative impact on your results, but confounders are notorious, or as we say here, especially egregious in distorting your results. Right? So both quantitative and qualitative were needed here, right? Or they're not needed in every study, but they were needed here because this is what would have happened. So the wrong decision, so if we were just looking at the quantitative data, the wrong decision would have been made about moving classes to the evening, right? Recall, quantitative analysis said class assignment's the big predictor, everybody likes the evenings, right? That's what the data said. That was incorrect. Now, if we did a purely qualitative study, it would have been inconclusive because the qualitative analysis identified themes, right? It said class instructor and class assignment are related to class attendance. But we couldn't compare them to see that when you consider instructor, right, class assignment no longer matters. You could only see that through our quantitative analysis, right? You can't see which variable trumped the other, right? So in end, qualitative analysis was instrumental in identifying, right, our confounder, like the class instructor. But after we identified it, quantitative analysis told us which was the more powerful predictor. So without the two strands of data, we couldn't have answered our research question correctly. All right, step 7, the write-up and report. Step 7 of the mixed method study we'll go over in week 6 of our webinar, which is actually called write-up and report. So it's appropriate. So the take-home message, right, based upon the data analysis, residents do not seem to be attending evening class because they want to attend evening class. Important point, right? They're attending evening class mainly to be instructed by Miss Albright. However, I mean, in fact, when class instructor is considered, class assignment is no longer related to class attendance, right? Also, keep in mind, barriers didn't impact class attendance, which is interesting too. So were they barriers? Just merely complaints. That's what it seems like. It seems like there were just, more complaints, but if they wanted to go, then the complaints, the barriers didn't really seem to matter, which is important to know because they could have had a large effect. Right? So in fact, residents want to attend class in the morning, so moving classes to the evening would be a mistake, ostensibly, right? And to answer the research question, the strongest predictor of class attendance is class instructor. So there we go. Answered our research questions. Now, this week we benefited from a large sample size of 100 people, right? Now, sometimes in qualitative analysis, you have a small sample size, 10, 20 people, which our statistics in this study, can't accommodate. So next week, in week 5, we will look at statistical analysis with small samples, meaning a small number of people in the sample. All right, well, thank you for watching, and I will speak to you then.